Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the second part of going through some EDEXCEL questions on inequalities, where we'll be looking at some of the hardest ones. This is obviously then for those students who are looking to get an 8 or a 9. If you haven't already been through the most common EDEXCEL inequalities questions, then check out that video first. So here we're going straight into regions inequalities. It's a little bit different than the one you might have seen in the previous video though, because we have it already drawn for us. So the shaded region shown on the grid is bounded by 4 straight lines, as you can see. Find the 4 inequalities that define the shaded region, and it's 4 marks. So first of all, we need to write down the equations of the 4 straight lines, and then we can try and figure out the inequality situation. So we've got 2 lines that are easier. Can you see this one that's completely vertical and this other one that's completely horizontal? Those will be the easiest ones because they'll be either just x or y and obviously then a number. So the horizontal one is at 6. Now you might think that x is horizontal, which the axis is, but if you think about it, at what point is it always the same number? Do you see how this is 6 all the way along, but the x values are changing? So therefore it's obviously y, isn't it? Y is equal to 6. So we've got y is equal to 6. The vertical one is, by the looks of it, at -3. And that one being vertical means that it's always at -3 on the x-axis, but the y-axis is changing, isn't it? So that's x is -3. Those 2 are the easiest ones because they are literally horizontal vertical. They are not diagonal. Now we have 2 more that are diagonal. So those ones we're going to have in the format of a straight line, which is y equals mx plus c. M is the gradient, c is the y-intercept. So let's do this one here that's going downwards. We can see quite clearly, I would say here, that the y-intercept is 1. So let's write that. We don't know what the gradient is just yet, plus 1. And then we have to figure out the gradient. So because we can see it in front of us, we can always pick 2 coordinates and then draw a little triangle. So we've gone 2 along, 1 down. The gradient is the change in y over the change in x. So we've got -1 over 2, which is -1/2 basically, isn't it? So that is -1/2. There's our equation for this diagonal one going down here. And the other diagonal one is going up, so it's going to be obviously a positive gradient. But first of all, y-intercept is at 6, so plus 6. And then let's choose 2 coordinates that we can see quite clearly. This one and this one. And we draw a little triangle. So it's going along by 2 and up by 6. So 6 over 2 gives us 3, doesn't it? 3x. So those are the 4 equations. Now, I would assume these would probably give you at least 2, if not maybe 3 marks for just getting all the equations initially. The last bit then is to convert them back into inequalities based on which part is shaded. So let's start at the top again with the easiest ones. Y is equal to 6. Is the shaded region greater than or less than 6? Well, seeing as it's below, I'm going to go with less than. So that one's quite easy. It is less than 6. But also, because they're solid lines, I'm going to put or equal to. If they had dashed lines, then I would say just less than 6. Because it's a solid line, I'm going to put equals to as well. Then the next one is also quite easy. X is equal to -3. Is it greater than -3 or less than? Well, it's on the right-hand side, so greater than, isn't it? X is greater than -3. So that's already 2 out of the 4. The last 2 are a little bit more complicated, but again, if you have seen my other video going through the regions inequalities generally, just think of the x side of the equation as the line. Is the shaded region above or below the line? So the first one we did was the one going down, wasn't it? Is the shaded region above or below the line? Well, it's obviously above that one, isn't it? So if it's above, that means y is greater than the line. Or in this case, y is greater than or equal to the line. And then the other one, is it above or below this steeper diagonal line? Well, it's also above, isn't it? So again, y is greater than the line. Anything that's got x and y in it, the x side, if you've got it in this format of y equals mx plus c, the x side, just imagine it as you're saying the line. And I find that makes it a bit easier. So that one was a bit harder because I think regions inequalities is quite a tricky topic anyway for most students, and then this is harder because we're doing it backwards. Okay, now we're on to question 23, which we can assume 5 marks is probably one of the last questions, if not the final question on the paper. It is non-calculator though, so that's just something to bear in mind. So here we've actually got a rectangle and a right-angled triangle. The area of the rectangle is greater than the area of the triangle, so that's where our inequality comes in. Find a set of possible values of x. So basically solve for x. So we first need an equation, or in this case, an inequality. The area is the basis, isn't it? So area of a rectangle, you multiply the length and the width, don't you? So 3x minus 2 times by x minus 1, that's the area of the rectangle. The area of the triangle is half base times height, or base times height over 2, depending on how you like to write it. So we've got base, which is x, times the height, which is 2x. And then instead of just writing equals, because they're not equal, are they? We have to put the inequality in. The area of the rectangle is greater, so the inequality is facing towards the rectangle. So that's the context there. I've just started out some context, and now I've created an inequality. At this point, we can put the context to one side and forget about that for a second. Now we're just looking at inequalities. So to solve this, I'm going to multiply everything, expand it all out. 3x squared minus 3x minus 2x plus 2 is greater than, half times 2 is obviously just 1, isn't it? So that's fine. And then x times x is x squared. Now, we've ended up with a quadratic overall. So to solve a quadratic, we normally either factorize, quadratic formula, things like that. Either way, I need to have all of the terms on one side of the equation and a 0 on the other. The way I decide which way round to swap the terms is to make the x squared still positive. So I'm going to move everything to the left. So if we subtract the x squared, we get 2x squared. Obviously, collect the like terms, that's minus 5x. Plus 2 is greater than 0. Okay, let me write that up here so we can have a look at it more clearly. So now I'm solving this. I'm most likely, especially because it's non-calculator, going to factorize it. If you want to go over factorising quadratics, then I will link all those videos down below. And then we solve it as if it's just like a normal equation. I'm just going to put equals here for a second so that we can solve it normally. So x is either a half or 2. Now I need to put that into an inequality. Now, as I mentioned in the previous video, you're either going to memorise which way round the symbol faces, therefore which way round my answer inequalities face, or you can use the logic of a graph. I'm just going to quickly do that. If you want to see an explanation, it's in the previous video. So we're facing towards the quadratic, which is above 0. So we're looking at these two bits here. Therefore, we've got x is less than a half, or x is greater than 2. Okay, so that's if we were to just solve a quadratic inequality with no context. The thing that we have to consider here is that we do have a context, and the context is shapes. So have a little look. Do either of these answers not make sense, or it's impossible, for example? So for the triangle, both of them could work. You could have a half. However, it says x is less than a half. It can't go to negative, can it? You can't have a negative side length. So that one, not really sure. If we then look over here at the rectangle, x minus 1, if you subbed in a half, 1/2 minus 1 is negative 1/2. And it's saying either that or less than that. That would be negative, guaranteed, and then even more negative, wouldn't it? The same as if you were to sub it in up here. So in this case, because of the context, I would say that this one, x is less than a half, is invalid. We couldn't have a shape that has a negative side length. So I would therefore go ahead and choose the fact that it says find a set of possible values for x. It's basically x is greater than 2, which would work for all of these, wouldn't it? They would all be positive, and even bigger than 2 would still be more positive. So this case was harder because we had to set up an equation, an inequality. You need to know how to set that up, and then you need to know at the end which one to choose. Okay, so the other way that they could make inequalities harder for higher tier is when you have two inequalities together. So here we've got n is an integer such that 3n plus 2 is less than or equal to 14, and 6n over n squared plus 5 is greater than 1. So we've got a quadratic one here and a linear one. Find all the possible values of n. So it has to basically satisfy both inequalities. So we need to solve both. Now obviously the linear one is much easier, isn't it? So let's start with that. Solve it like a normal equation. So minus the 2 is 12. Divide by 3 gives us n is less than or equal to 4. Put that to a side for 1 minute. We grab this quadratic one, we need to solve this. So currently we've got a fraction, which is obviously quite annoying. So I'm going to multiply by n squared plus 5. Now, if you're wondering whether we know, because obviously we don't know what n is, whether that's an issue in terms of multiplying or dividing by a negative, n squared, whatever n is, even if n is negative, if I square it, it makes it positive, plus 5, positive. So I know for a fact n squared plus 5 is a positive. So when I multiply by that, it's not going to swap the symbol. Because you know with inequalities, if you multiply it or divide by a negative, it swaps the direction of the symbol. Don't worry about that in this case. I know we don't know what n is, but we know that n squared is always positive. Plus 5, more positive. So don't worry about that, that's fine. Now, because it's quadratic, I'm going to move everything to one side where the n squared is positive. So I'm going to move the 6n. And then I'm going to factorize this. And then solve that. Just for now, I'm going to put the equals so I can then put my symbols back at the end. So I've got n is 5 or 1. Then based on the fact that I normally use a little graph to figure it out, as I said, you might just memorize which way around the symbol faces, therefore which way around the answer is. So because we are saying that the quadratic is less than 0, so 0 is this line here, we want this part, so n is between 1 and 5. Therefore we've got 1 is less than n, which is less than 5. So now I've got two inequalities. I'm going to write them over here. N is less than or equal to 4, and 1 is less than n, which is less than 5. I need to find now an inequality that would summarize both. Now you might be able to just see it from there. That one's not too difficult to figure out. If you can't, sketch a little number line with all those numbers on it. Draw both separately, so n is less than 4 or equal to, so colour that in. Arrow. And then this one is 1 to 5. And then you see where it overlaps. So can you see how this is the bit that overlaps? So my inequality is 1 is less than n, which is less than or equal to 4. Now, the last thing to consider is, what was the question? Did they ask for an inequality, which is this? Or, in this case, did they say find all the possible values of n? So that's saying list them, list the values. N is an integer, it's a whole number. So which values does this inequality encompass? Well, obviously 2, 3, and 4, isn't it? Doesn't include 1 because it's greater than 1, not equal to. So my answer is actually 2, 3, and 4. So just double check, was my question asking for an inequality or was it asking for a list of values? That's the other thing to just double check. Okay, our last question is very similar. It's also a really hard one because we've got two inequalities, but this time they're both quadratic ones. So find the set of possible values of x for which 4x squared minus 25 is less than 0, and 12x minus 5x minus 3x squared is greater than 0. That one's actually a negative quadratic as well. Obviously, you must show where you're working. So we want to solve these. The first one, I'm hoping that you'd recognise it, is difference of two squares. It is a quadratic. We can factorise it into double brackets. It's just difference of two squares. 2x plus 5, 2x minus 5. Difference of two squares can come up in loads of different topics within your exam, but it will definitely come up somewhere. I can guarantee that pretty much. So solving it, we get minus 5 over 2, or obviously positive 5 over 2. Now, putting that back into an inequality, as I said, I like to use my graph method. You might just prefer to memorize, if the symbol faces the 0, it means this answer. If the symbol faces the quadratic, it means the other answer. That's up to you. So here we're saying it's facing 0, so it's less than 0. So we're looking for that bit, which means it's a range. So x is between negative 5 over 2 and positive 5 over 2. So that's that first one solved. Let's do the same thing over here. Now this one's a negative quadratic, so what I'm going to do, I think, is move everything to the other side and make it positive. Just because I don't really want to have to factorise it with a negative one. You can, obviously that's fine, you can do that, it is possible, but I would just rather not. It's also non-calculated, so I am assuming that we can factorise it into two brackets as well. and then solve that as well. So we get 4/3 or -3. Now to put that back into an inequality, -3 4/3. This one was facing the 0 as well, so it's also a range. Obviously put the smallest one on the left. Okay, so now we've got the two separate. We need to put them together. Again, you can draw a number line if you like. This one's not as ideal because they're not all whole numbers, but that's fine. I'm just going to put them roughly in order. So that's what we've got, the two separate ones. And where they both overlap is here. So -5/2 or 2.5 is the lowest number, and then 4/3 is the highest number. Now, let's go back to the wording of this one, because it says find the set of possible values. The set is another way of saying an inequality, isn't it? So for this one, we're not going to list our answers, because they also haven't mentioned that x is an integer, have they? They haven't said it's a whole number. So the answer is, in this case, the inequality. Whereas the previous one was saying n is an integer and find all the possible values of n, so find the values. Whereas this one said find the set of values. So you can see how sometimes they might ask for a list of values, sometimes they ask for the inequality. Just double check which one they've asked you. So that is everything on Edexcel past paper questions for inequalities. If there's any of the parts of those that you'd like to look at in more detail, I'll have all of the individual inequalities videos down below, also any other things such as factorising as well. Thanks for watching this video. If you found it helpful, make sure to like and subscribe, and if you have any questions, leave them down below.